Okay, so today we are talking about the fundamental theorem of algebra. The first thing we're going to talk about is the rational zero test. And this one is, as long as I have a polynomial that has integer coefficients, then every rational zero of the function fits the form p divided by q, where p have no common factors other than 1. P is a factor of my constant number at the end, and q is a factor of my leading coefficient. So number 1 wants me to find the rational zeros of 2x cubed plus 3x squared minus 8x plus 3. So what I want to do here is I first want to find my factors of p. P is my end number. So what are my factors of 3? 1 and 3. And what I'm going to do is I'm going to do plus and minus 1 and plus and minus 3. I honestly do not know why I gave us so much space on number 1. Then I'm going to go ahead and do the same thing for my leading coefficient. This one is the q. So I'm looking for my factors of 2. I know why I gave us so much space, because it said find the rational zeros. Okay, so what are my factors of 2? Plus or minus 1 and plus or minus 2. And then I want to find p divided by q. So I'm going to take all my values of p and divide by, I'm going to start with the 1. So plus and minus 1 divided by plus and minus 1 is still plus and minus 1. Plus and minus 3 divided by plus and minus 1 is still plus and minus 3. 1 is a number that multiplies to 2. Okay. Then I want to divide my other numbers by Then I want to do the same thing for the 2. I want to go ahead and divide my factors of p by the 2. So I'm going to have plus and minus 1/2, and then plus and minus 3/2. Did it? There we go. Okay, so then because this one is asking me to find the rational zeros, I need to actually go and solve this. If it had just said find the possible rational zeros, I would be done. So if I had the word possible, I'd be done. But I'm not. So what I'm going to do is I am going to use synthetic division to test these numbers that I got. So then I'm going to write out my coefficients from my original polynomial. 2, 3, -8, 3. And then I like to start with my smallest numbers. Projector isn't that bad today. So do you want me to start with positive or negative 1? Okay. So we'll test out a positive 1. I bring down my 2. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 8 plus 5 is negative 3. Negative 3 times 1, negative 3. 3 minus 3, 0. So is this one a factor? Yes. So I can either use synthetic division again, or I can turn this back into a quadratic and factor. What do you want me to do? I'm pointing at that stuff on the bottom in case you can't see with the projector. And then it like speeds through it. It's cool. You want me to do synthetic division again? That's what Jamie said. I didn't hear anyone else. Well, factoring, I won't have to test every value and get things that don't work. Okay. You were the only one who was giving me an answer. That's why I was talking to you. Okay, so I wrote out the polynomial. So how do I factor this? Once my hand is out of the way. Okay, so my A value is 2, and my C value is negative 3. So then if I take A times C, I have 2 times negative 3, which is negative 6. Yeah, 6 and negative 1. I wrote something. We'll see. There we go. Then I'm going to split up my middle term into those two factors. So I'm going to have positive 6x, negative x, and then minus 3. Then I want to break it up into two groups. That's not green. What divides my first group of 2? 2. Okay. And I'm left with, what can I take out of my second group? And what am I left with? And we'll wait for my projector. Okay, so then I want to write my two outside terms together. So this question is asking for rational zeros. I want to take those and set them equal to 0. Okay, so on the first one, I add 1 to both sides, and then I get 2x equals 0, and I mean 2x equals 1. And then I divide both sides by 2, so I get x equals 1/2. Then I want to do the same thing for the other one. I'm going to subtract 3 on both sides, and I get x equals -3. And then I don't want to forget about the one that I used synthetic division on, so I also have x equals 1. Questions here? There's one more answer that's not showing up on me. There it is. Because it's already set equal to, it's already been solved. Okay. Questions? Any other questions? The one was the synthetic division number I used. I can use any number, but 1 was the first one that worked. So if I had tried -3, it would have worked, but if I had done like +3, it wouldn't have. Okay, so now we have the fundamental theorem of algebra. No, it's the hand dryer from the bathroom. The fundamental theorem of algebra is basically taking the rational zeros and then just rewriting them as factors. So factoring, using the zeros to factor the polynomial. What? So like, basically we're adding one more step to the last thing we did. Okay? Okay, so what are my factors of p? Okay, what are my factors of q? Okay, so p divided by q is going to be, what are all of those numbers divided by 1? So why did I divide all those numbers by 1? Yep. Okay, so then I want to use synthetic division to test these out. What do you want me to try first? 1 or -1? Okay, I heard a -1. So remember, I don't have an x to the 4th, so I wrote 0 as a placeholder. Okay, so then this 1 comes down. 1 times -1 is -1. Okay, well I'm going to go ahead and see that for myself. -1 times -1 is 1 plus 1 is. So you guys say you don't understand this, and then you're just having casual conversations. 2 times -1 is -2. 2 minus 2 is 0. 0 times -1. -12 minus 1. -13 times -1. I was just writing what you guys were saying. mean it's a factor. No. So I need to try again. Positive 1. Okay, so did 1 work? 1 worked. Okay, so I want to keep using synthetic division. If I could factor it if I want to put it back into a polynomial form. This one should give me up to 5 zeros. So I'm going to use synthetic division until it's a quadratic. So what number do you want me to use next? You really want me to go to 8? 2? I could have done 1 again. Yeah, because if it works, I can reuse it.
With those current numbers at the bottom?
Yep.
Oh, we should have done that then.
Okay, so 2 gave me 32.
Let's just do what you said. Negative. No, let's use the one with the current numbers. You said that we could use it. And it comes to 1, 2, 4, 8. I don't know why I'm putting it.
I know we already did 1. We can reuse 1. I have said this multiple times. And 1 worked again. Wait, I used the wrong numbers.
Yeah.
I would have never guessed it would work.
Does it still work though? Okay. So 1 works again when I write the right numbers. Do you want me to turn it, this one will give me a cubic. Do you want me to turn it back into a polynomial, or do you want me to keep using synthetic? What number do you want me to try? So, all of these numbers are positive, so I should try something that's negative so that it'll cancel out. Okay, so, negative 2 worked. Yeah, x squared plus 4. Uh-huh. No. Because... Okay. So this one wants it as a product of linear factors. So which numbers did work? Okay. So when I write this as a linear factor, I change the signs. So I had 1 that worked once. I had 1 that worked twice. I had -2, so that should be +2 as a factor. And then I need to make this a linear factor. So notice it has a plus sign in the middle. So if I had set this equal to 0, yep. So I take the square root and I get an imaginary number. So then I'm going to have x plus 2i times x minus 2i for my last two factors. So this is my answer. They're not going to work, Iris. What? It's not missing any numbers. I could have. I was just writing it twice to show you that you got it twice. So in this one, I want to find all the zeros, given that 1 plus 3i is a 0 of f. Whenever I have complex numbers, their conjugate is always another 0. So what I know is that I have x, and then remember, zeros are always opposite signs, what they really are. So I'm going to have minus, parentheses, 1 plus 3i times x minus 1 minus 3i. Conjugates just change the sign in the middle. I was missing a parenthesis here. So then what I want to do is I want to go multiply those two together. I am going to multiply on a sticky note. I like using the box method when I have three terms. But I'm going to distribute out that negative. So I have, for the first one, I have x minus 1 plus 3. If I distribute it out, that's going to be x minus 1 minus 3i. And then for my second one, I have x minus 1 minus 3i. When I distribute out, that is going to give me x minus 1 plus 3i. So these two values are the ones I'm multiplying together. So I want to go ahead and set those up with a box. I'm going to write the first one on top and the second one on the side. I didn't need to draw these lines, they're already on there. Then I want to multiply in each of my boxes. I have x times x gives me x squared. X times -1 gives me negative x. X times negative 3i gives me negative 3ix. Negative 1 times x is negative x. Negative 1 times -1 is positive 1. Negative 1 times negative 3i is positive 3i. X times 3i is 3ix. 3i times -1 gives me negative 3i. 3i times negative 3i gives me negative 9i squared. Then I want to go ahead and combine like terms. So I have my x squared. Then I have negative x and negative x gives me negative 2x. I have 3ix and negative 3ix, so those two cancel out. I have 1. I have negative 3i and 3i. Again, those cancel out. I have negative 9i squared. Remember, when I have an I squared, this means it's really negative 1. So I have negative 1 times negative 9. This gives me positive 9. Then I want to combine like terms. So I have x squared minus 2x plus 10. So then what I want to go ahead and do is, with my original polynomial, I'm going to use long division here and divide it by that factor I just got. So I got x squared minus 2x plus 10, and I'm dividing into x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. Then what I want to do is I'm looking for what multiplies x squared and turns it into x to the fourth. This is another x squared. I distribute, I get x to the fourth minus 2x cubed plus 10x squared. So then I want to write those under the matching terms. Okay, and then I want to change my signs. So then the x to the fourth cancels out. Negative 3 plus 2 is negative x cubed. Positive 6 minus 10 gives me negative 4x squared. I want to drop down my remaining terms. Then I'm looking for what, oops, I forgot to write what I multiplied up above. Then I'm looking for what multiplies into by x squared to turn it into negative x cubed. This is negative x. So it's going to give me negative x cubed plus 2x squared minus 10x. I'm going to write the negative x up here. Then I want to go ahead and write this down below. I apologize for not giving us enough room. Then I'm going to change my signs and add. So then my x cubes cancel out. I have negative 4x squared minus 2x squared gives me negative 6x squared. Oops, I wanted this in blue. Positive 2, positive 10 gives me positive 12x minus 60. Let me go grab a piece of paper. Okay, so I have copied this all over on another sheet of paper. Now I need to turn x squared into negative 6x squared. This would be multiplying by negative 6. And I write that over. I get negative 6x squared plus 12x minus 60. So then I'm going to write this over here. And then minus 6 was what I multiplied by. Good news here. When I subtract these out, they cancel out, which gives me 0. That means that this number I initially divided by is a factor, which it should have been because I knew, given one of the conjugate zeros. So what I want to do here is I want to factor this remaining answer I've got. So I'm looking for what multiplies to negative 1 and adds to negative 6. That is negative 3 and positive 2. And then I want to go back ahead and add in those other zeros I got at the very beginning. So these two zeros, or the ones I wrote up here. I'm going to write the ones where I've already distributed. So I had x minus 1 minus 3i, and then times x minus 1 plus 3i. So those came from my very beginning. Actually, just kidding, I didn't want these as factors. The question said find all the zeros. I didn't need to go that far. So I had x minus 3, x plus 2 from factoring this. Then I want to take these two and set them equal to 0. So if I add 3 on both sides, I get x equals 3. I subtract 2 on both sides, I get x equals negative 2. So I know 3, negative 2, and from the very beginning, I know 1 plus 3i, and then 1 minus 3i are zeros, because conjugates always come in pairs. So this one was number 5, and I will work through 6 since we didn't get to it in class. Let me just copy it down on my piece of paper. So I have f of x equals 3x cubed minus 2x squared plus 48x minus 32. And then my 0 is 4i. So now that I've copied this over, I can put these one. It's not as bad as the last complex number. I have x minus 4i, and then I know my conjugate is changing the sign on my I term, so then it's going to be x plus 4i. So then I want to multiply these two together so I can figure out what my polynomial is, and then go ahead and divide this one by that. So I have x times x gives me x squared, x times 4i gives me 4ix, negative 4i times x gives me negative 4ix, negative 4i times positive 4i gives me negative 16i squared. I go to combine like terms. My 4ix's in the middle cancel out. Negative 16i squared turns into negative 16 times negative 1, which gives me x squared plus 16. So I'm going to go ahead and use long division to simplify this. Then I'm looking for what I need to multiply x squared by to turn it into 3x cubed. This is a 3x. So 3x times x squared gives me 3x cubed. 3x times 16 gives me 48x. So then I want to make sure I write these under the correct matching terms. I have 3x cubed goes here. 48x goes under the 48x. Then I want to change my signs. These two cancel out. I drop down my remaining terms. So I have negative 2x squared. This one is in the middle, so I'm going to keep it as a 0x. And then minus 32. I'm looking for what I want to write this up above. I'm looking for what I need to multiply x squared by to turn it into negative 2x, which is negative 2. Then I want to distribute, so I get negative 2x squared minus 32. So I'm going to write this out over here. And I multiplied by negative 2. Good news again, these completely cancel out, so that means I found that first factor complement correctly. Then I want to take my 3x minus 2 and set this equal to 0. I add 2 to both sides. I get 3x equals 2. Divide both sides by 3. X equals 2/3. Then I knew 4i, because that one was given, and its conjugate is negative 4i. So those are my answers for number 6.